Okay, Wildcats. Today we're looking at putting the v in absolute value. Defining absolute value functions and transformations. Warm-up. Graph f of x equals x is shown. Graph each transformation. Alright, so let's go ahead and graph 1 in yellow. So we have to remember that it says right here that the function f of x equals x. So every time we see f of x, we know it's x. So this can be rewritten as f of x plus 5 as x plus 5. Okay. So let's go ahead and use Desmos. So I'm going to go to graphing calculator, x plus 5. And let's just go ahead and pick 2 points. These pop out automatically. So let's go ahead and use that. -5, 0, and 0, 5. And so we correspond correctly. I'm going to come over here. I'm going to change the color. Well, they're using red, so let's go ahead and use red. And I don't see yellow as an option. So let's go ahead and change this color to red. It's an option. All right, so -5, 0. So -1, 2, 3, 4, 5. 0, 1, 2, 3, 4, 5. And the transformation is up 5 units. All right, let's go ahead and graph this one in green. So this 2 times f of x minus 3 can be written as 2x minus 3. All right, so I'm going to press enter, and then I'm going to graph 2x minus 3, and I'm going to change the color since I chose green. So we'll come over here, change that to green, done. And let's pick some points that we can use. 0, -3, and 1.50 work okay. But maybe, can we use a whole number? 2 1's probably better. Let's do that. So let's use 2 1, 2 1. Okay. So 0, -3. And 2 1. Nope. Yep, 2 1. All right, and that transformation is a vertical stretch by 2 and down 3 units. Well, let's take a look at the next one. Let's do this one in blue. So 1/2 times f of x minus 1 can be written as 1/2 x minus 1. Let's go ahead and do that. 1 divided by 2 x minus 1. And let's go ahead and change that color to blue. And let's pick some points. That might be okay. Let's see if we can find any other one. 0, 1. That's a little far out. Let's use 0, -1, 2, 0. So 0, -1, and 2, 0. Okay, and that transformation is a vertical pressure by 1/2 and down 1 unit. All right, go ahead and finish up the warm-up, and let's take a look at the next page. All right, distance is always positive. The teacher works A, C, E, and G, and the student works B, D, F, and H. Okay, so let's go ahead and do that, and let's go ahead and use Desmos. So let me open another tab. Scientific calculator. Let's get this out of the way. And there should be absolute bars. Yep, that one right there. So I'm going to press that, and we're going to put in -2. And so the value is 2. And then we're going to press this again. 1 minus 2 is 1. press this again. 1 minus 2 is 1. 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 1 minus Negative 2 times 3 is 6. And press this again. Is 12 divided by negative 3 is 4. Alright, go ahead and finish up A, C, E, and F, and then do B, D, F, and H on your own. Alright, let's take a look at the next portion. 2. Write your observations about the absolute value expression you and your classmates modeled on the number line. Distance is always positive or 0, so the absolute value of an expression is always positive. We didn't do that, so let's go ahead and mark that out. Alright, go ahead and mark out 3, and let's take a look at the next page. Okay, let's take a look at 2D 4.1, graphs of absolute value functions. Follow your teacher's instructions to model the function f of x equals x on the classroom coordinate plane with your classmate. Okay, so f of x equals x, so f of negative 9 equals negative 9, f of negative 6 equals negative 6, f of negative 4 equals negative 4, f of negative 1 equals negative 1, f of 0 equals 0, f of 3 equals 3, f of 5 equals 5, and f of 8 equals 8. And since we're graphing points, we don't need Desmos, so we just use whatever color we want, so let's graph that in yellow. Okay, so negative 9, negative 9. So negative 1, 2, 3, 4, 5, 6, 7, 8, 9. Negative 1, 2, 3, 4, 5, 6, 7, 8, 9. Negative 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Negative 1, 2, 3, 4. Negative 1, 2, 3, 4. Negative 1, negative 1. 0, 0. 1, 2, 3, 1, 2, 3, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6, 7, 8, 1, 2, 3, 4, 5, 6, 7, 8. All right. Let's go ahead and graph this in blue. So f of negative 9 equals the absolute value of negative 9, which equals 9. F of negative 6 equals absolute value of negative 6, which equals 6. F of negative 4 equals the absolute value of negative 4, which equals 4. F of negative 1 equals the absolute value of negative 1, which equals 1. F of 0 equals the absolute value of 0, which equals 0. F of 3 equals the absolute value of 3, which equals 3. F of 5 equals the absolute value of 5, which equals 5. F of 8 equals the absolute value of 8, which equals 8. So let's go ahead and graph those points. So negative 9, negative 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Negative 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Negative 1, 2, 3, 4. 1, 2, 3, 4. Negative 1, 1. 0, 0. 1, 2, 3. 1, 2, 3. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And then 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. All right, go ahead and finish up the table and graph. All right, number 2 we just completed. Number 3. Describe how the points move from the graph of f of x equals x to the graph of f of x equals absolute value of x. The points of the function f of x equals x that have a negative x coordinate are reflected across the x-axis. 4. Graph the function f of x equals absolute value of x. Describe the characteristics of the functions you've noticed. The vertex is at 0, 0. The domain is all real numbers, and the range is y greater than or equal to 0. Let's take a look at the next page. Next, consider the function f of x equals negative x. Model this function on the classroom coordinate plane with your classmates. Okay? So, and again, let's just do this in yellow, and then let's do this in blue. So, we're basically plugging in 9 for x. So, that becomes negative times negative x, or negative 9, I'm sorry, equals positive 9. Negative times negative 6 equals positive 6. Negative times negative 4 equals positive 4. Negative times negative 1 equals 1. Negative times 0 equals 0. Negative times 3 equals negative 3. Negative times 5 equals negative 5. And negative times 8 equals negative 8. Okay, let's go ahead and graph those points. So negative 1, 2, 3, 4, 5, 6, 7, 8, 9. Up 1, 2, 3, 4, 5, 6, 7, 8, 9. Negative 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Negative 1, 2, 3, 4. 1, 2, 3, 4. Negative 1, 1, 0, 0. 1, 2, 3, 1, negative 1, 2, 3. 1, 2, 3, 4, 5, negative 1, 2, 3, 4, 5, and 1, 2, 3, 4, 5, 6, 7, 8, negative 1, 2, 3, 4, 5, 6, 7, 8. All right. So now here we have the absolute value of negative times negative 9 equals positive 9. The absolute value of negative times negative 6 equals positive 6. The absolute value of negative times negative 4 is equal to 4. The absolute value of negative times negative 1 is a positive 1. The absolute value of negative times 0 is equal to 0. The absolute value of negative 3 is 3. The absolute value of negative times 5 equals 5. The absolute value of negative times 8 equals 8. Okay, let's go ahead and graph those points. So negative 9, 9 is right here. Negative 6, 6 is right here. Negative 4, 4 is right here. Negative 1, 1 is here. 0, 0. And then 1, 2, 3, 1, 2, 3. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And then 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. All right, go ahead and finish up the graph and table. All right, let's take a look. We've completed number 6. Go ahead and mark out 7 and 8. Let's take a look at the next page. Activity 4.2, transformations outside the function. Consider the function shown. G of x equals absolute value of x, c of x equals absolute value of x plus 3, d of x equals absolute value of x minus 3. Use technology to graph each function. So let's go ahead and do red here, let's do green here, and let's do blue here. Okay, so I'm going to go to Desmos. And I'm going to X out our previous graphs. So we have I believe the absolute value button is right here. So absolute value, oh, I'm sorry. G of x equals the absolute value of x. Okay, let's pick 3 points. So this is a good point. That's a good point. And that's a good point. So let's go ahead and graph those. So 0, 0, 1, 2, 3, wait, negative 1, 2, 3, 4, 5, positive 1, 2, 3, 4, 5, positive 1, 2, 3, 4, 5, positive 1, 2, 3, 4, 5. Okay, now let's do, oh, let me change the color. Sorry about that. Red, done. Now let's take a look at the next one. C of x equals the absolute, oh, we're still in that same graph. Let's come back here. Absolute value of x plus 3. Okay, let's pick 3 points. This seems to be a good point. Negative 2, 5, and 2, 5 seems to be a good point. Okay, so 0, 3, negative 1, 2, 1, 2, 3, 4, 5, positive 1, 2, 1, 2, 3, 4, 5. And almost forgot, let's change that color to green. Done. Okay. All right, and then last one, enter d of x equals oh, why are we still here? Let's go here. So value of x minus 3. And let's change the color. I think we said blue. Done. So let's use this point, this point, this point. Okay, so 0, 1, 2, 3, negative 1, 2, 3, and 1, 2, 3. All right, go ahead and finish up the graph. Let's take a look at number 2 and 3. 2. Write the function c of x and d of x in terms of the basic function g of x, and describe the transformations of each function. The points of the function f of x equals x that have a positive x coordinate are reflected across the x-axis. The points with negative x or x coordinates do not move. And let's just come up here to do the transformations. This is up 3 units, and then this is down 3 units. Okay. Number 3, describe the similarities and differences between the 3 graphs. How do these similarities and differences relate to the equation of the functions g of x, e of x, and d of x? The graphs of f of x equals absolute value of x and f of negative x equal the absolute value of negative x are the same. All right, let's take a look at the next page. Recall that a function t of x of the form t of x equals f of x plus d is a vertical translation of the function f of x. The value d describes how many units up or down the graph of the original function is translated. Describe each graph in relation to the basic function. G of x equals absolute value of x, then use coordinate notation to represent the vertical translation. A. F of x equals g of x plus d. Vertical transformation up d units. B. F of x equals g of x minus d. Vertical transformation down d units. Go ahead and mark out C. Consider the absolute value functions. G of x equals absolute value of x. J of x equals 2 times absolute value of x. K of x equals 1/2 absolute value of x. And P of x equals negative absolute value of x. Use technology to graph each function. Okay, so let's go ahead and use red, green, blue, and okay. So let's go ahead and come back over here to Desmos. Let's clear out each of these. So we have g of x equals value of x. Let's get some points. There you go. So let's graph those points. So 0, 0, negative 1, 0, 1, 0. Okay. Excuse me. All right. Let's take a look at, oh, and let's change the color there. I almost forgot. Sorry, we said red. Done. Let's take a look at the next one. J of x equals 2. Oh. Okay, and let's pick some points. This point looks good, and negative 5, 10, 5, 10. So let's use that. Okay, so 0, 0. And actually, I think 1, 2, 3, 4, 5. Those are a little high, so let's see if we can go pick something lower. That might be what we have to do. Negative 2.55 and 2.55. So negative 1, negative 2, 0.5's up here. 1, 2, 3, 4, 5. And then 1, 2, 0.5, 1, 2, 3, 4, 5. And I believe 0, 0. We said green. Okay, now let's take a look at the next one. We have k of x equals 1 divided by 2. Value of x, and what do we say, blue? So let's come over here, change the color to blue. Done. That point looks good. I think that might be too far, so let's see if we can find something better. Negative 5, 2.5, and 5, 2.5. So let's go ahead and use that. So negative 1, 2, 3, 4, 5, 1, 2, 2.5. Positive 1, 2, 3, 4, 5, up 1, 2, 2.5. And we said blue. Okay, and let's take a look at the last one. P of x equals negative x, and let's pick some points. So 0, 0 is good, negative 5, 5, and 5, negative 5. So 0, 0, negative 1, 2, 3, 4, 5, negative 1, 2, 3, 4, 5, and 1, 2, 3, 4, 5, negative 1, 2, 3, 4, 5. I believe we said that's in black. Oh. All right, go ahead and finish up the graph. All right, let's take a look at 6. Write the function j of x, k of x, and p of x in terms of the basic function g of x. Then describe the transformation of each function. The graph of j of x is a vertical stretch of 2 units. The graph of k of x is a vertical compression of 1/2 units. The graph of p of x is reflected across the x-axis. Let's take a look at the next page. Recall that the function t of x with the form t of x equals a times f of x is vertical dilation of the function f of x. The a value describes a vertical dilation of the graph of the original function. Describe each graph in relation to the basic function. G of x equals absolute value of x. Then use coordinate notation to represent the vertical dilation. A, f of x equals a times g of x when a is greater than 1 is a vertical stretch by a units. B, f of x equals a times g of x when 0 is less than a and a is less than 1 is a vertical compression by a units. C. f of x equals a times g of x when a is less than 0. It's a reflection across the x-axis. Go ahead and mark out D. Let's take a look at the next page. Go ahead and mark out this page. Let's take a look at this page. Given the function f of x equals absolute value of x, use coordinate plane to show the answers question 10 through 14. And you know what? Let's just go ahead and call it, and we'll go ahead and call that page. All right. So with that, go ahead and finish up your notes and have a wonderful Wildcat day.